Ladies and gentlemen, prepare to be stupefied. Maybe not stupid, maybe the opposite of stupefied. Is that smartified?
Edified?
We are inside the think tank at the Imagination Station with the chief scientist, Carl Nelson, who is ready to get down on Pi Day. Got to get down on Pi Day.
Yes, tomorrow is Pi Day, right? So some people may not know what Pi Day is. I think we're geeks, we get it, right? But Pi Day, pi is that constant, the ratio of the circumference of a circle to its diameter.
I see.
Turns out to be like 3.14 are the first few digits. And so March 14th is traditionally celebrated as Pi Day.
I know those other digits. It's 3.14159265358.
Well, okay, you jumped ahead, and that's okay. You know what?
Yeah.
The easy way to remember some of this stuff, people memorize pi to these insane number of digits, and behind you is something called a piam, okay? And it's actually pretty cool. Count out the digits in the words to me.
Oh, it's like a poem.
Okay, do it.
Like, okay. Three. 1, 4, 1, 5. Immutable.
Count it.
9.
You looked over there. Okay. Anyway, you get the idea. So it's like, if you memorize that piam, it's like a play on poem, you, with the number of digits, can remember pi to like 35 digits.
It's like a paiku.
That's a whole different thing.
Oh, man.
There are haikus as well. Yes.
Really?
So, okay, so that's pretty cool. And we've calculated pi for over thousands of years. And right now, I think the record is like 50 trillion digits.
Wow.
Which begs the question, why? I mean, there's lots of reasons why, but like, do we need 50 trillion digits?
No.
No, we don't. No.
Okay. I thought that was rhetorical.
So this, right here, this number of digits of pi, 15 digits of pi, is all that NASA uses to do their spaceflight missions. That's all the precision they need.
Lazy NASA workers.
Okay. Don't be that mean NASA.
No.
So with that amount of precision, you can calculate where the Voyager spacecraft is beyond the orbit of Pluto to within an inch.
Wow.
It's insane. If you took that to 40 digits, you could calculate the volume of the known universe to within the size of a hydrogen atom.
Man.
So going to 50 trillion digits is a bit insane. But for me, I thought it would be really cool to see, we talk about pi, we talk about using pi to measure the circumference and diameter and things like that, but how do you actually calculate pi? Archimedes had a way a long time ago. So we're going to do it right here really quick.
All right.
Little math lesson. If I have a circle, okay, in red, its diameter is 1. We are going to estimate its circumference by enclosing it in a square that is tangent at all 4 points. And so the perimeter, Tony, of this square, the length all the way around is?
Pretty impressive.
1, 2, 3, 4.
Yeah.
Okay, and then we're going to put another square on the inside. Okay, and now we need to figure out what the perimeter of that square is, because pi is somewhere between 4 and the perimeter inside here.
Okay.
This is where Archimedes looked to Pythagoras, Pythagorean theorem. A squared plus b squared equals c squared for a triangle. We're going to look at this triangle right here. Okay. This side A and this side B are equal.
Okay.
And we know it's actually 1/2 because this is 1/2 of the diameter of the circle, right?
Sure.
So A equals B equals 1/2. So we simplify, we get c squared. We can figure out what c is. This hypotenuse is about it's the square root of 1/2, which is roughly 0.7. So we take 4 times that, we get 2.8 as the perimeter of that one. If we add that to the 4, which is the perimeter on the outside, and take the average, we get 3.4 as our really crude estimate of pi. Now we know we're off, but this is the simplest way we could do it. Archimedes, instead of using squares, used hexagons, then heptagons, then decagons, and on and on and on. And the more you increase the number of sides on the inside and the outside, the closer it gets to the circle, and the closer your approximation is going to be. Right? Isaac Newton got to 16 digits, which is more than NASA uses right now, back in the 1700s.
Okay.
So it's kind of it's interesting geometry of how you actually calculate pi, as opposed to just using it to calculate something. You can actually create it. Now, today computers don't do that method. They have other ways that are much faster.
Yeah. Right.
But
we'll just use the calculator and just, pretend like we know what we're talking about.
But so interesting. Number of digits of pi. Number of digits versus time. Right? From 2500 BC, it trickled along, got a little bit bigger, and then in 1947, invention of the pocket calculator and computers.
Good old Texas Instruments.
We're about at 1,000 digits of pi right here. All of a sudden, it goes into 50. Now we're at 50 trillion.
Wow.
It's insane how, for most of humanity, we were living with like 16 to 20, maybe at the most 1,000 digits, right? But then after 47 and the calculator computer, it just exploded.
What hath technology wrought? All right. Well, it was a good lesson here. How do you like them apples, Newton? And that's how you imagine it.